Hello guys and welcome to MathStudio Showcase number 2. Last time we were looking at how to use MathStudio to simulate waves that are interfering, that are superposing one another, destructive and constructive interference, and standing waves. So that's kind of basic. Today we're going to look at the capabilities of MathStudio that allows you, the user, to create a function or a method or a class or whatever you call it that you can use later on to call in your like subsequent programs. All right. And for example, you can name something like a cube program. So you can what it does is it takes any number, and the basic thing that it can do is it will take that number and then raise it to the power 3 with the cubing program. But you can create any program you want. And again, I want to emphasize again that you can use MathStudio offline and you can do this on your cell phone. So today we're going to do scripting. We are going to apply the idea of scripting in a phenomenon in nature known as random walk. And basically random walk is you have something, a particle or a person, a walker. We call it a walker, not the zombie from Walking Dead, but since he is random walking, he is a walker. And basically, when you are a random walker, your steps are dictated randomly, hence the name random walk. So for example, you start at the origin. The simplest case that I'm going to talk about is you start at the origin and you're only confined to move left and right. Okay, and what dictates your movement? You get a coin, and if you flip it, if it is if it's heads, you move right. If it is tails, you move left, and so on. So for example, you start at 0, you throw a coin, it's heads. So I go to position 1. You throw the coin again, it's again heads. I go to position 2. I throw the coin again, now it's tails. I go to 1, and so on. And you keep increasing that depending on how many steps you have, okay? And again, if you want to learn more about the nuances of random walk, because it's an amazing topic on its own, this video won't be about that. So this video will focus on the capabilities of MathStudio to simulate such a phenomenon that is random walk. All right. If you want to learn about random walk, there are like a lot of videos in YouTube or other stuff that you can read to learn more about it. But after learning that and then you want it to simulate on your cell phone, this is the video for you. Okay. Let's define a script. In order to define a script, we use the @ symbol. I forget the name of that symbol, the @ symbol. And let's call our script random walk. And you introduce a parenthesis and you tell it how many parameters it will have and what it will receive. So in this case, it will receive the parameter n, which is basically the number of steps of your random walker. So you can give the random walk script that you are doing n equals 5, n equals 10, n equals 100, and so on. So what we do is we create a variable known as start, and basically how we are going to simulate random walk is we are going to save the information of its position. So note that is one-dimensional. The walker is at the origin and it moves either to the left or to the right, dictated by a coin, whether it's heads or tails. So now, in order to do that, we are going to keep the information of his position. So it is a list that would say, for example, 0, 1, 2, 1, and so on. So we want to save that list. And in order to do that, let's define a list of size n. And so that we want it to be simple, let's call the starting value of the list. So this is how you do it, start 1. And let's set that equal to 0. So what we're saying here is, okay, you have a list that is of length n. The first value, set it to 0 because we want our walker to start at the origin. How do we make it walk? Well, let's introduce a for loop. For I from 1 to n, here's what we're going to do. Let's introduce an if statement. Now, let's pick a random number between 0 to 1. Okay, why are we doing this? Because we are simulating the flipping of coins, the throwing of coins. So, if the random number between 0 to 1, let's say, is greater than 0.5, greater than 1/2, then this is our heads, for example. So if the random number between 0 to 1 is greater than 1/2, what do? Well, let's take the next position, which is I plus 1, and since we want it to move to the right, let's take, so the next position, the I plus 1th position, will now take the value of the first position, which in this case, when I is equal to 1, is just 0, plus 1. All right. Then, else, okay, if it's not greater than 1/2, in other words, it's less than 1/2, else, you take the value of start at I plus 1, you set it equal to the initial value, start I. Instead of moving to the right, what do you do if it is less than 1/2, if it is tails, you move to the left. So minus 1. And then let's press enter. Let's end the if statement, and then let's end the for loop. And after making a script, what you do is you return the variable after you call the script. It has to return something. For an input n, it has to return something. In this case, it will return a list of n length. So just to test if it is working, so let's press enter here. Let's give another variable m, which we will be adjusting, that will dictate the number of steps that we want. So let's just set it to 10, for example. Then let's call a variable, I don't know, v. Let's call it v. This will receive the value of the list that will be returned by random walk when your input is m, in this case 10. So let's press enter. It's an error. So let's figure out what's wrong here. Line 5, start is out of bounds. Line 5. I know the problem. The problem is, since start only has n steps, in your if statement, you're calling start I plus 1. When I has a value of n, you add it by 1, you're going beyond the length of your list, the start list. So in order to mitigate that problem, let's just define start to have a length n plus 1. Doesn't matter, right? N plus 1. Okay, so now we shouldn't have that error, so that now when I becomes n, you still have start n plus 1. Okay, let's press enter. Now this is your list. So it starts at the origin. He tosses a coin. The coin was tails, so it went to -1. He tossed the coin again. It's heads. He goes to 0. He tossed the coin again. It's heads. He goes to 1. He tossed the coin again. It's heads. He goes to 2, and so on. Now, if we want this to analyze it even better, we introduce something known as list plot. Okay, so let's plot. Let's look at the actual position of the random walker on the x-axis. So list plot will take an input of the list. So in this case, the square bracket, the orange one, will have 2 elements. The first element will be the list itself, which is v, and then let's have another list of length m. Okay, a list of length m plus 1 actually. Okay, so what it does is, because the list plot, you will give it a pair of values if you're using this list with 2 elements. So v is the information of the position of the walker. When you do at m plus 1, you're creating our list containing all zeros. Why do we want that? Because we want to see the actual motion of the random walker. We want to confine him at the x-axis. So you think of your list v, this 0, -1, 0, 1, 2, and so on. Those are your x values, okay, your x coefficients, and then your at m plus 1 list, a list of length m plus 1, is a list containing all zeros. So in other words, all your y coefficients are equal to 0. Okay, so let's press enter. And so you see, I don't like it because you can't really tell anything. So what we can do is, first of all, let me change the color to blue, because I kind of don't like the default violet. And then let's say we want to see the points. By default, you're not seeing the actual positions of the coefficients, so let's give it a size. By default, it's 0. Let's give it a size of 5, for example. Let's press enter. There you go. Okay, so in this particular random walk, it began at 0, and then it went to 1, sorry, it went to -1, and then it went back to 0, then to 1, then to 2, then to went back to 1 again, went back to 2 again, then to 3, went back, and then went all the way up to 4. The problem with this is that eventually when you increase m, the future positions will be overlapping. And so what we can do to mitigate that problem so that we will have even more information is that we can use something called a bar plot. And what it does is it takes your list, for example, V, and then let me give it a color, I don't know, green. Okay, so now what bar plot does is it takes your list, in this case 0, -1, 0, 1, 2, 1, and so on, and then it makes a histogram depending on the number of occurrence of that particular value. So for example, in our V list, 0 occurs twice, okay, so it will have a height 2, and then 2 occurs 3 times, it will have a height 3, and so on. So let's press enter right here, and there you see the bar plot. Okay, so now that's the information of the different positions of the random walk. And again, if you're a bit familiar with the random walk, for this simplest case, one-dimensional and then dictated by a 50-50 coin, so he can either move to the left or to the right. The distribution, if you make m big enough, it kind of approaches a bell curve. Okay, so let's say I make m equals 100, for example, and then let me run again the bar plot. So now, of course, when m is equal to 100, it doesn't always looks like a bell curve, but you make it like a very large. I don't think my tablet can like accommodate like 10 billion, for example, but yeah, it kind of looks like that. So here you see that the bell curve, if you make m approach infinity, the bell curve will be like centered at the origin, because that's the expectation value of your random walker. Here it's shifted slightly to the right, meaning when your random walker did its walking, he got heads most of the time. So let's run it again, and then again. So now you have a different bar plot. Now this looks a bit kind of like a Gaussian. I like it. Yeah, but let's not stop here, because last time we introduced a concept of the slider, correct? Okay, we have a slider called S, for example, whose value will be from 1. In this case, we want to slide it up to the number of steps. So from 1 to m plus 1. M plus 1. Okay, and then let's press enter. Okay, so now you have a slider. What is happening? Sorry, I introduced the slider, but then it's not using the list plot, and bar plot is not using the variable S. So let's edit our list plot. So now instead of list plotting the whole list V, we now restrict it so that it's only plotting V starting from 1 up to the value of the slider S. Also the bar plot, let's restrict it so that it's just bar plotting the value of V from 1 to the value of the slider S. Okay, let's press enter, and I don't like it, it has a shade. So let's go back to list plot. So by default sometimes it's on, I don't know why. So let's set shade equals 0. There you go. So now let's move the list. Oh, you see there? So S equals 1, S equals 2, S equals 3, and you're doing the random walk. So now here, since the information of the position of your random walker on the x-axis is already kind of encoded in the bar plot, why don't we, instead of plotting its position on the x-axis, why don't we make our x-axis as the number of steps, and then the y-axis its actual position? Okay, so now when you do that, what you'll see is now you will have a line that will move to the right. So it's plotting as n increases, the number of steps increases, this plot will be moving to the right because the x-axis now corresponds to the number of steps, and then its height, its y value corresponds its current position. Okay, so let's simplify it again. Let's make it m equals 10 so that you can see it. So to do that, let's remove the y equals 0 values. So by default, if you give the first parameter of list plot, the list itself, instead of the list containing 2 elements like we did a while ago, the second element being y whose values are all 0, let's just give it the list itself. So what it does is every increment, every n, it will plot the value of your list. So let's run m equals 10. So now our first value is 0. So what this does is, if you plot it at n equals 1, the first step, you're at 0. At the next step, you're at 1. So that's the y value. Next step, you're at 2. That's the y value, and so on. So in order to see that, let's run this. And then let's do the, see? So that's what I was talking about if you do the slider. So it's now telling you the, so at the 11th step, for the example, the last one here, the last position in your list V is now at 0, and you can see that in the blue plot, the last value is y is equal to 0. Okay, and we can even increase that. We can make like m equals 100. Okay, and so now you press enter here, and then you do the slider. So now it's now at the negative value. So in this case, what happened is that the worker obtained a lot of tails, and so he was like constrained on the left side. Okay, and if you can, the nice thing about the blue plot, if you notice, is it kind of emulates, you know, the ups and downs of the plot in the like stock exchanges. So that's why some people, in fact, if they want to model or study that, they use random walk to model the behavior of the ups and downs of a stock market. Okay, but anyway, let me introduce you something even cooler. Because slider, you've already seen this before. Another thing that MathStudio can do is it has this awesome thing called Animate. Okay, let's use the same variable s, and what Animate does is, so before in showcase number 1, we saw that you have the variable capital T, which always has the value of time. It moves in time. But Animate, you can dictate a variable s to move at your pace, at your own pace. Okay, so it's like slider. You have a variable s, its range, so from 1 to, again, up to m plus 1, the length of the list. And then the fourth parameter, I believe, is the increment. So we want our s to be animated such that it increments per step. And then the fifth parameter is the starting position. So let's make it start at 1. You can make it start at 5 or whatever, but let's make it start at 1. And then the last one is the frames per second. How fast your animation animates something. So let's give this 60, for example, so that you can see. When you press enter, it does it automatically, but 60 looks too fast. So usually for my case, I use 10. Okay, and then you animate it. Jug, 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 jug. Ah, that is so cool. That is so cool. So let's have another values of m. Then let's run the animation again. Dug, 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 dug. I am random walking. The green histogram is the frequency of the position. The blue plot is the actual the position of the walker as a function of the number of steps. Okay, so it's doing that. Let's make it 1000. M equals 1000. Now this is going to be awesome. M equals 1000. Let's press enter. So you have a list containing 1000 positions. And then let's go back to this one. Let's plot it again. Then let's magnify it. Okay, so you can see it animating on its own while this particle or this guy or whatever the hell this is random walking for 1000 steps. Okay, and so you can see in the first part of its random walk, it's like on the positive side, and then now it's on the negative side. It's almost hypnotic, you know. So let's make it run up to 1000. And then let's pause it the moment it reaches like 1000. Come on, random walk some more. 900. Yeah. Oh, that was a good pause. So s equals 1000. So you see there the random walk, but you can go on the bar plot and then magnify it, and you can see the distribution of the different positions, you know. Again, this should approach a bell curve, but again, 1000 is not that large, but you get the idea. Okay, so let's make it again smaller so that, you know, our screen won't be cluttered by this a lot of lists. Let's just make it m equals 10, and then let's run again the animation. Let's play it. And then the moment it reaches the last step, it stops. Okay, let's stop the animation at s equals 10. Okay, let's make another script still related to random walk, but this time this is even more awesome. Why? Because what we're going to do is we are going to make our walker do a random walk on a 2D plane. A while ago, we're constraining him on a single line. He can only move left or right. Now, what if he can move, in addition to left and right, what if he can also move up and down? Okay? And so now his movement, his or her movement will now be dictated by not just a coin, heads or tails, but a four-sided die. What's a four-sided die? So if you don't want to imagine like four-sided die, dice have like six sides. But anyway, forget about the dice. So instead of like tossing a coin, if it's heads, you go right. If it's tails, you go left. Do this. Get two coins. You toss it. If it's heads, you go right. If it is tails, you go left. If the first one is heads, and the second one is tails, you go up. If the first one is tails and the second one is heads, you go down. Okay, so now you have four options, and so again it will still receive n, the number of steps, but this time we are gonna introduce a list. Let's call it start x. This time it will have two lists, so this will have length. Let's make it n plus 1 again so that we won't encounter the error we've seen a while ago. Start y equals a list of length n plus 1. And again, we have to initialize them. We want to start at the origin, so start x at 1 should have a value equal to 0. Start y at 1 should have a value. Wait, I messed up. The keyboard is covering the typing area, equal to 0. Is that fine? Okay. And then we do our for loop again. That's what we did a while ago. And by the way, the nice thing here is that once you're done with your script and then you're sure that it works, you can actually collapse it. So you have like a little arrow here to the left of the random walk label. You can tap on it. It will collapse the script. Okay, so let's do this. So now we introduce a for loop for I from 1 to n, the number of steps. If let me introduce you so that we won't keep on typing random 0 1. Okay, so random 0 1. Okay, so now let's go to our if statements. If you, so now a while ago our benchmark was just 1/2. If it's less than 1/2, move to the left. If it's greater than 1/2, move to the right. Now we have to divide the distribution from 0 to 1 into 4. So from 0 to 1/4, from 1/4 to 1/2, from 1/2 to 3/2, and then 3/2 to 1. Okay, so that you have 4 instances. So the first one, let's say if u is less than 1/4, what do we do? What we do is we set the I plus 1 position of your along the x to be the starting position of your x plus 1. All right? And your y, the I plus 1th position of your y, will just be equal to the initial position of y. Okay, so what's happening here? So what's happening here is, what's happening here is, if u is less than 1/4, so this is corresponding to your heads, for example, you move right. Okay, so you do nothing to your y position, you move to the right in your x position. Else, if u is greater than 1/4 and at the same time less than 1/2, u is less than 1/2, what do we do? Let me just copy this so that I don't keep on typing that again and again. So copy, let's paste it inside our first else if. So this time let's move to the left instead of moving to the right. Okay, and then else if u is greater than 1/2 but at the same time less than 3/4, what do we do? Let's paste this one, the one we copied a while ago. But this time, do nothing on the x. This time, we move up. Okay, and finally, of course, the final, let's just write else. That's just like the final condition is when u is greater than 3/4. Let's paste everything else, but let's edit it. Do nothing on your x position, but in your y position, move down. So let's end our if statement. Let's end our for loop. And then now, we need to return a list containing two elements. The first one is the list of information of the x position. The second one contains the list of information of the y position. Okay, let's just see if it works. So now let's use another variable. What was the number of events a while ago? I believe I called it m. Let's use, I don't know, w, for example. W equals 10. Okay. So now let's give the value that is being returned by random walk 2D to a list containing two elements, x, y. The list x will contain the value of start x after being run by random walk 2D, and then y will contain the list of start y. Okay, so how you do that is you equate that into random walk 2D script evaluating the number of steps equal to 10. So let's press enter just to make sure. Yeah, so you see there. So you're starting in the first list, you're starting at the origin 0, 0. At the first throw, at the first step, what he did is, I believe the second one is y. Yeah, what he did is he moved up. In the second step, he moved to the left. In the second step, he moved to the right, and so on. Okay? And now, let's do the awesome things that we were doing a while ago. Let's again animate S from the initial position up to m plus 1, the increments, the starting position, and then what was the FPS we used a while ago? I believe it's 10. Yes, we did. And then let's do list plot. Okay, so this time we are plotting a list. Okay, a list which have two elements. So this time our element is x, but we want to plot x, not all of x, but from 1 up to the value of the slider s. And then in the second element of this list, the parameter of your list plot, we are plotting the list y, but not everything, just from 1 up to the value of the animation. Okay, and what did we do a while ago in our start plot? Let me go back. We set a color. Okay, so this time let's set it, I don't know, red. And then we turn the shade off. And then we set the points to be equal to 5. Okay, let's enter. Now it's animating and doing a random walk for number of steps equal to 10. So let's make it so that we can appreciate it better. Let's make it 100. Let's random walk with 100 steps. Go. What's it doing? No, I did not press enter in here. I did not evaluate it. Sorry, not random walk 10. Random walk W. That's why it's always using 10, because random walk should have an input W, which we are setting as the number of steps. So anyway, let's make enter. So we have a list here containing 100 pairs of numbers. Let's plot it. And now it's random walking in 2D, although it's not, because why is it not random walking in 2D? Because we are animating up to m plus 1. I'm an idiot. Now the variable is W. M was the one for 1D. Okay, so let's enter. And there you go. 100 steps of 2D random walking. Okay, let's make it, I want to make it 1,000. Okay, boom. You have 1,000 pairs of events. Let's animate that. It starts at the origin and then it's random walking. Okay, so yeah, it's very hypnotic, you know. So 2D random walk, it has, at any point in its position, it can move either up, down, left, or right. In fact, you can even do like diagonals. You can do, instead of 4, you can have like 8. But you can do that on your own. It's easy. You just edit the for loop, or you add in the if statements. Instead of your benchmark, instead of being 1/4, 1/2, 3/4, now it will be 1/8, 2/8, 3/8, and so on, because you have 8 different instances. Then you will have diagonals. But yeah, anyway, it's awesome. So again, you can do this offline on your cell phone. Okay, so like now you're doing in your phone, and then your mother or your parents will be like, "Hey, what are you doing? You're always looking at your phone. Do something productive." And then you'll be like, "What are you talking about? I'm simulating random walk in 2D." Okay, so yeah, but again, yeah, that's like one of those things that Math Studio can do. It is really fascinating, and I really love this app. So again, if you like doing these things, again, it's not this like, how do I use, how do I like present that? No, that's not the point. The point is you can do some toy models before doing it in the actual computer. Like if you're like before going to bed without your laptop or whatever in your cell phone, can I do this program, this algorithm, will it work? And Math Studio, you can do your benchmarking on Math Studio. But yeah, anyway, I'll stop it right here, and I hope you learned something today in doing the random walks. In first we considered it in 1D, and then we introduced the awesome capability of Math Studio, which is that of Animate, and then also of scripting. It opens a lot of possibilities, because basically you can write programs. Okay, that's what you can do. And yeah, and then we extended it into 2D and made this amazing plot of a walker, which starts at the origin but then wanders up in the 2D plane after 1,000 steps. So let me just give it another, let me collapse the script right here. Let's give it another set of 1,000 events, and then let's make it walk randomly. Okay, and then I'll just leave it to run like that, and then yeah, I'll see you next time. I hope you learned something, and I hope you're gonna try this yourself. It's really very fascinating.